Okay, hey guys, so today we are doing number 4 from practice 1 on page 160 and 161. We're going to do this one together. Your homework tonight is to complete number 5, okay? I will create another video with number 3 if you want a little bit more support. But let's start by taking a look at question number 4. So the rainbow panorama is an architectural work of art on top of the Aarhus Art Museum in Aarhus, Denmark. It was designed and created by the Danish Icelandic artist Oliver Eliasson and completes the building's representation of hell, purgatory, and paradise, inspired by Dante's work, The Divine Comedy. I'm really glad that this is the example problem that we have because Oliver Eliasson is one of my favorite artists. He's really cool. You should check him out if you don't know him. But let's get back to it. The journey to paradise ends at the panorama, which presents visitors with amazing views of the city bathed in different colors. The glass artwork consists of a 3-meter wide circular walkway in all of the colors of the spectrum, and its outer diameter is 52 meters. Okay, so this is some important information that we want to start collecting. When you're solving word problems, you must draw pictures. Otherwise, it's all of this information that just doesn't make sense. Okay, so let's take a look back here. Okay. And I've also cut out some little things. So it has a walkway. Oh, shoot. Let me go back. All right. So it has a 3-meter wide circular walkway in all the colors of the spectrum, and its outer diameter is 52 meters. So let's go ahead and let's take a second and let's draw these pictures and record this information. Okay, so we have a circle. My circle has a diameter of 52 meters, and we know that there's a walkway that is 3 meters wide. Okay, so already we've got that information. That's really important to have. Now let's go back. Okay, so A, if you walked in the middle of the walkway, okay, so this is our walkway. If you walked in the middle of it, calculate the distance you would walk to complete the circle. So the distance you would walk. So again, if this is my walkway and I'm walking along this path, here as I go, I'm gonna kind of change it so that way my color becomes orange, right? If I'm tracing around it like that, I'm not coloring it in. So what is this question asking us for? Part A, what information are we looking for? So if I walked, just like I drew that red circle on my walkway, if I walked here, what is that called when you trace a circle and to find the length of it? We're looking for a word. We're looking for a word. Stop the video, take a second and think, what is the word that would trace around that circle, that red dotted line? It's your circumference. And the equation we're looking for is going to be C equals, can you finish it for me? Pi 2r, okay? Now that we're here, we need to start identifying some key information, okay? So if I'm gonna walk in this red dotted circle, let me come down here. I need to know what is the diameter of that circle. And so I have to figure that out using the information that I already have. So I know that from here to here is 52. And I know that this distance here is 3 millimeters. If I walk in the very middle of this 3 millimeter hallway, that means that there's going to be 1.5 meters on both sides of me. So if I have from here to here is 52, what would the distance from here to here be? Well, it would be 1.5 meters shorter on the left side and 1.5 meters shorter on the right side too. So my diameter here is going to be 52 minus 3, which is 49. If you didn't get that, pause, rewind, listen again. So we know it's 52 minus 1.5 minus 1.5, or 3, which equals 49. Okay, so our diameter for this circle is 49. I don't want to emphasize that, so I'm just going to cross out. The diameter is 49. But we need the radius. And we know that our radius is going to be half of this number, but that also we could logic that if the diameter is equal to 2 of our radius, then instead we could say circumference is pi times d, because d is 2r. So to find our circumference, we're going to multiply pi times 49, and that's going to give us an answer of 153.9 meters, okay, for 4A. So remember, try to draw pictures wherever possible to solve these. Let's look at part B now. So it asks, what is the area of the floor inside the walkway? So here's what we're asking now, right? So if I'm looking at it from above, so here I'm looking for the walkway floor. If I'm looking at it from above, what I'm looking for is what is the area of the green shaded region. Okay, what is the green area? And well, we don't know what that is. I don't know how to calculate what just this space is, but let's take a look at the information that we do know. So I know that I've got my outer circle with a diameter of 52. And then I also know that I've got a smaller circle. I'm not exactly sure what the diameter of this one is, but I could probably figure it out if I wanted to. I'm not looking for either one of these, but instead I'm looking for the third, the green space that is with the difference of the red and the blue, right? So I want to take away the blue in order to get to my green, okay? How am I gonna do that? Well, I know if I've got my large red circle, I've got my small blue circle, I know that the diameter of this circle is 52. And I know that because it told me in the initial problem. So my radius is going to be 52 divided by 2, which is 26. So when I'm looking at my blue circle, I can use my red one to find that because I know that my walkway is 3 meters here and 3 meters here. And then I'm going to have my blue circle on the inside. It kind of looks like a Pokeball. Now, what would I do to find the diameter of my blue circle? We're going to take 52. We're going to subtract 3 on the left side. We're going to subtract 3 on the right side, which is going to give us 52 minus 6, which is a diameter of 46. If we want to find the radius, that's going to be 46 divided by 2, which is 23. Okay, so now to find the area of a circle, we need one of 2 equations. You tell me which one is it going to be. If I'm looking for the area, which one is it going to be? That one. A for area, C for circumference. Okay. So we're looking for the area of the red circle, and then also the area for the blue circle. Let's do the red circle first. So the equation is A equals pi r squared, and the area for this one is going to be pi r squared. So now I plug these into my calculator and I find the respective areas. So the area of the red circle is going to be 2,123.7 meters squared. And the area of my blue is going to be 1,661.9 meters squared. So I know the area of my large red and the area of my small blue. Now, in order to get my green walkway, I'm going to take my red, subtract my small blue, and it's going to leave me just the green walkway inside. And my difference is going to be 461.8 meters squared, okay? This is our walkway area, okay? Great. So I'm gonna divide this up so that way it's obvious where my work is. Let's go back to our book. So now the last question, C, the height of the panorama is 3 meters and its inside and outside walls. Its inside and outside walls are made of glass, okay? find the area of glass required to build the walls of the structure. Okay, find the area. First, I'm going to record that information that I have now. Can I? No. I'm going to run out of room. Maybe not. Let's see. Okay, so for C, I know that the height is 3 meters. Oh, I'm going to not do that just in case I run out of room. Okay, so my height is 3 meters. And I have 2 circles, right? So for this, I'm going to look back at our equation that we were using Monday and Friday. So the surface area of a cylinder, because when we're looking at this, this is like the walls of that cylinder, right? We don't have the tops or the bottoms, just the walls. So the equation we're using to find the surface area of a cylinder is we had 2 pi r squared plus height times pi 2r. And when I'm looking at both parts of this equation, there are some important pieces that I need to think about. So this first half represents something, and this second half represents something else. Do you remember? This represents the circles, the top circle and the bottom circle. This represents the cylinder. So when I'm trying to find the surface area of just the cylinder part, which part of this equation will I eliminate? I do not need this. Actually, I do not need this because I don't have a top and bottom circle that I'm looking for. So I just want this for my inside and my outside circle. So when I'm looking at this equation here, well, the height for both my large cylinder and my small inside cylinder, the height for both of these is going to be 3 meters. The height for both is 3. The radius, I already know the radius for my big circle is 26. And I already know the radius for my small circle is 23. So now I just need to substitute my values. Height is 3 times pi 2r. Height is 3 times pi 2r. Again, I'm getting that equation from right here. Okay, now I calculate, and I get 490 on my large cylinder. So that is the area of this rectangle. Okay. And then the area for my small rectangle of my small cylinder, when I turn it into a rectangle, is going to be 433.5. But I don't want to just know one, I want to know both of them. So in order to know, these are both made of glass. These are both made of glass. In order to know the total glass that I need to take this and add it to this. So I'm going to take those two values, 490 plus 433.5, and it's going to give me 923.5 meters squared. That's how much glass I will need in order to create the walls for my cylinder. Okay, so when you're solving word problems like this, you need to slow down and not think, this is the information that I don't have, but always start, what do you have? What are you looking for? It's always important to understand. What are you looking for? And then see if you can find what you need given what you have. Remember to draw pictures. If you need to, cut out shapes. That's a great way to do it too. But really try and go slow and think through this. So I want you to try to do number 5 for homework. I want you to submit pictures on the Google form. Please, please try and do it through the Google form. When you submit it, I want to see drawings. Okay? Do not just give me numbers. All right? You must draw pictures. Okay? But before, so I'm going to take a quick screenshot of this. Before I erase it. Let's take a second and let's look. Well, let me erase it first. Okay. Let's look at the next problem together. So that way you understand the language first. So one of the tallest trees in the world is a giant sequoia tree named General Sherman in California, USA. With a height of 84 meters and an average diameter of 8 meters, the tree can be modeled by a cylinder. So here's that important information you need: a height of 84 meters and a diameter of 8 meters. Okay, remember, I'm going to want you to draw a picture. Find the surface area of the tree that could be used to carve a totem pole. Okay, a totem pole, they described this a little bit earlier in the chapter. We didn't go through part of that, but it's like a sculpture. A totem pole is a sculpture that's shaped like a cylinder. So it asks, find the surface area of the tree. Okay, find the surface area of the tree given these dimensions. Let's look at B. The next largest giant sequoia, General Grant, has a height of 81.7 meters and an average diameter of 7.6 meters. Find the difference in surface area between General Grant and General Sherman, the two trees. So it's saying find the difference, find the difference. When we're looking for the difference, which one is it that we're looking for? Addition, subtraction, multiplication, or division? Multiplication. So, and then thirdly, for C, find the height of a giant sequoia. So it's saying find the height of a giant sequoia with the same surface area as General Sherman, but an average radius of 9 meters. Okay, and those are some, be mindful of the difference that we've just seen here. So with our first, with General Sherman, it has a diameter of 8 meters. With this new tree, it has a radius of 9 meters. Okay, so notice that it's not both diameter or radius. One is diameter, the other one is radius. Okay, so that's going to make something different. And if it says that it has the same surface area, what is that surface area going to be for this one? It's going to be the answer from question A. Okay. I'm going to take another screenshot of the Earth. I'm going to post all of this for you on ManageBack. Again, if you have any questions, please don't hesitate, ask me. And thanks for watching. How's that like awkward time where I'm still trying to close down the program?